Everyone has an act. I know you were singing. How are you? Good to see you. What's your name?
Professor.
Good to see you, Professor.
I'm CEO and founder of Synergy.
Fantastic.
Nice meeting you.
Fantastic. So we got some battery technology?
Yes. Yeah. This is fully electric.
Oh, look at this. This is a good-looking car.
Thank you.
What's this called?
The made is not really important. The important thing is the technology inside.
The technology in the back.
This car drives 200 miles on one charger. And it's all based on this aluminum air technology. This battery utilizes aluminum, water, and air. Air is available everywhere. You don't need to carry. Aluminum is a light metal. And water you can pump in every 200 miles. So this is actually the best battery in terms of density that you can find today. And with this, basically, the problem of range anxiety, which usually
is holding back.
Holding back is gone. 200 miles is no limit anymore.
It's also a new city car. So what allows for the kinds of efficiencies that you're getting?
You can see that. This is actually the fuel. This is aluminum. This is half a kilo of aluminum. And our technology, Synergy developed technology that started in Barilan. This is Professor Saban, he actually invented it. And we are a commercial company that managed to release the vast energy that is in aluminum. The way we do it, we have actually, this is a breathing air cathode. Air comes from this side, and there is water in this side. We refill the car with water, and the reaction that is being done here actually makes the aluminum dissolve into the water until it nearly evaporates. So if you hold this piece, you see it's much lighter than this one.
This is how it starts.
It starts like this, and gradually it goes to here. This is the fuel. Yeah. Actually, one plate like this, let's say 20 plate like this, takes a mid-sized car 55 miles per hour for 160 miles. And this could be as, I would say, emergency backup system for domestic use, let's say natural diseases and things like that. The important things I would like to share with you is actually we teamed recently with Alcoa, aluminum company of America.
So the CEO class just a few days ago.
Did he mention something about it?
He didn't say that, but...
so he keeps secrets very nice.
You know, that's exactly right. He figured he wanted to make sure that he's got this all...
So Alcoa would manufacture the fuel.
The Alcoa will manufacture the fuel and supply. We signed with the French OEM for producing the car. We'll be very honored to do something with America as well.
Now what's the economics behind
it is cheaper than fuel, it's zero emission, and it's fully recyclable. Actually, a kilo of aluminum is around $2, and when you sell back the residual that comes in the water, it's about $0.50.
How would I get that if I'm driving a car?
You should not do anything, because actually...
Are you replacing the battery on a regular basis?
No, we're reducing it. So instead of having, let's say, 150 or 160 miles with large 300 kilogram, we go to maybe 50 kilogram. This gives you your daily average. So you go from the grid daily average, but you're carrying on board an onboard generator that whenever you depleted your daily grid-oriented electricity, you are with no range anxiety. With this amount of water, we can release equivalent of 350 kilometers, 200 something miles.
Basically, you will have to put new aluminum once a year.
Once a year.
But when you go to change your brakes.
But these you just install in the battery itself.
Each one of them.
You can basically slide one in.
It's already installed.
Here it is.
Came in here driving.
This is the way it slides in. And the garage, the periodic maintenance every 20,000 kilometers will replace this. And this is a half an hour job. And actually...
Is there a car company that is going to pick up on this?
Is there?
It sounds like a French company.
Yeah, there is a Renault Nissan signed with us a contract towards 2017 to have a serial car with this technology.
Excellent. Well, congratulations. You need to talk to Ford or GM, though.
If you have some connections, do you have some connections?
I have a few connections with
maybe some influence.
Well, what you can do is send our team your information.
If it is okay with you, we'd like to speak about more things with you. And there's a lot of ideas. You're a group of experts.
What I'll do is I'll have my team follow. Okay?
Thank you very much.
Thank you very much. Congratulations.
Yeah, looking forward.
Thank you so much. Thank you. Somebody want to grab my aluminum here? There you go.
Well, I could change a few things.
Absolutely. How are you, sir?
What's your next? Hello, Wolf. I'm a professor of mechanical engineering from
Great to see you, Alan.
Hello.
What about you?
The worm. The worm.
I was reading about this. You can send it into rubble.
Yeah, so the idea is to send the snake into the house building, and we're actually going to present you two types of snakes. One is for surgery, the other on the screen, and this is for search and rescue. The idea came after the unfortunate event of 9/11, where the robot that were used to try to locate survivors were not good enough to go on the collapse problem. So we started to think out of the box. I wasn't Carnegie Mellon, that's a faculty. We started to try to develop something that looks like a snake, probe. It's about 8 pounds, and it's very flexible. Has the motors, computation, everything built inside. Camera, any sensors that
Each link is independent.
its link is completely independent. And what we do is try to ease the snake into the building. Actually, we're trying to minimally interact with the building itself. So first thing you can do is actually drop something. Communication server, sensor, something to keep in the building. You can actually also take a better look to the camera and have a higher elevation view of the surrounding area inside.
Let me just say, my wife would not like this.
As opposed to biological snakes, this snake can also roll, and this is remarkable.
Now, is this all remote controlled with the autonomous?
Yes. It can roll, and actually, if you need to break it into 2 parts or more, what you can do is break it in the middle and have one part go to one room, the other part go to another room, so you save time. You can make the snake as long as you want. There is no limitation for the length of the snake itself.
And in terms of sizing it up, is it something that?
Yeah, that's
This is standard, but are you able to make smaller ones, larger ones?
So that's a good question. So this is the smaller one. This is the surgical snake. It's about
It goes into the body.
1/3 of an inch. About this diameter is about this diameter, and it's about 30 centimeters long. And you can drive it into someone's body. This is a company now in Boston, located in Boston. My colleagues are from Harvard Medical School and from Carnegie Mellon. So this is heart surgery.
So for microsurgery, this would be.
You don't need to open the person anymore. So surgery is going to become an intervention.
Just to get into the cavity, then you've got enough space, you go inside, get to the point, just do it.
And you use the flexibility of the snake to crawl around organs and ease yourself into the operational site. This is how the system would look like in the operating room. And the surgeon drives the head of the snake. The rest of the snake is following the head. That's why we call it to follow the leader. And you just perform the surgery. The surgery is now an outpatient-based procedure. So you don't need to hospitalize the patient. You save money. The risk for, of course, getting infected is reduced dramatically. And
That's remarkable. Well, you can see obviously all kinds of applications for this.
yes.
So
One
congratulations.
for search and rescue, one for surgery.
When you come in currently now?
In 2006.
Well, we want you back.
Thank you.
Congratulations.
Thank you.
Oh, who's this guy? How are you? What's your name?
My name is Amir Geva. I'm the founder and the chief scientist of the Minda and the professor in Vancouver.
Hello. Wonderful to see you. Thank you so much.
Hello.
All right. So tell me what you got going on your head here.
So first, we were delighted to hear about your announcement in the State of the Union about the brain mapping project. Since that's exactly what we are doing in my research in the university in the last 20 years, and that's what we are doing in Minda in the last 7 years. So Ronen will present you our functional brain imaging technology.
Great. So every good mapping starts with a good measurement. So I first measure the brain of here, and it's 128 electrodes that are put on his scalp. And how does that feel?
Like a hairnet.
It measures the
You have to presuppose that there is something to measure, right?
Exactly.
We'll see in a minute. So it measures electrical activity, which are generated by his neurons, so it's neural activity. So clearly what we first see is that Amir is alive. That's a good sign, it's a good start. His brain is functioning, and we measure it while he's performing a certain task, in this case a game which is evoking certain functionality of his brain, like attention and memory. And while he's performing it, we measure his brain. So there's nothing new about measuring brain waves, but our first breakthrough is the ability to take these signals and separate the signal from the noise. Now the second part is going to the next one, is the ability to take this code and decipher it into meaningful clinical information, namely millisecond by millisecond visualization or reflection of brain functional activity. So in order to demonstrate that, I will demonstrate it on traumatic brain injury and concussion, which is a very important topic and a cause of serious public health concern. And I will show you a 17-year-old high school football player who got head-to-head collision during a football match and got a severe concussion. So looking at the current standards, if you take his neuroimaging or CT scan, he's completely normal. Looking at his symptoms, which were very high at the beginning, but they are resolved within 3 weeks. And his neuropsychological or performance, cognitive performance, is pretty flat and non-conclusive, so he returned to play in 3 weeks. When we look into his brain with our DNA technology, looking at his brain networks, first looking at the baseline of a healthy net, we can clearly see that once he's concussed, you don't have to be a physician to see that something is really going wrong with his brain network activity. So following it over a course of 4 weeks, we clearly see that this particular 17-year-old guy...
He should have stayed out for 4 weeks as opposed to...
Exactly. Because after 3 weeks, his brain activity was not yet resolved. So what excites clinicians and parents alike is the ability to really see what is going on in this person's brain. So we have
So is this primarily a diagnostic tool, or are you able to actually pinpoint from a treatment perspective?
What we're showing you here is a diagnostic platform, but we have a treatment platform as well, that if you see a malfunction, we'll try to fix it with a neurostimulation of electrical current injected into the brain. But this is the diagnostic part and the monitoring part. And we have some significant collaboration with the University of Pittsburgh Medical Center, and in particular with the medical staff of the Pittsburgh Steelers, with the University of Michigan, with Robert Kraft and the New England Patriots, and also recently, thanks to the introduction of Dr. Pullman, we initiated the research with the Navy, and also we are in discussion with Walter Reed, traumatic brain injury, in order to be able to baseline kids, athletes, and soldiers, and be able to monitor them once wounded. So this is very exciting for us, and who knows, maybe a better understanding of the human brain not only will help us treat brain injuries better, but also maybe will help us communicate better with our neighbors and make peace.
Congratulations.
Thank you very much.
Good luck. Now, I did leave some marks on your head, though. They'll go away soon. Congratulations. How are you? What's your name?
Amnon Shashua.
Nice to see you. Hello. Hello.
I'm co-founder of the company. Both are co-founders. I'm a professor of computer science also at the University. We developed a system on chip. So this is what we developed. Yeah. And this system processes visual information for driving assistance systems. So the system watches out, looks for pedestrians, looks for people, for cars, lane marks, traffic signs, and watches out for an accident. And when that is about to happen, an actual series of signals that actuate warning and then actual automatic braking happens.
Pedestrians too.
Pedestrians, cars, dogs. not dogs, pedestrians and pets.
For small children?
Up to 80 centimeters long. A few months ago, we shipped our 1 millionth chip. Today it's about 1.5 million. So there are 1 million cars worldwide driving with our chip. And we work with most of the car makers, including GM, Ford, and Chrysler.
It's an alarm? It produces an alarm?
An alarm and also automatic braking.
Automatic
braking. Now the field itself is entering into regulatory phase, where star rating incentives are pushing the industry to offer this as a standard fitment. And that will save many
How much does this cost to install per car?
Well, the car manufacturer pays around $100. And if it comes through regulation, star ratings, then it comes for free, just like airbags and stability control.
The only thing here is I have to be a little careful because we actually have a regulation that we're dealing with right now.
We know.
The Department of Transportation.
Well, of course.
So
the regulation language should be written around their product.
So I may have a conflict here in terms of, but it's remarkable the progress that you've been able to make.
Additional to that, our technology is not limited just to new vehicles.
Yeah.
It could be easily installed in
Into
any
all
vehicles that already
You
on the
just
road.
take,
This is the aftermarket product, yes.
You just put this,
Yeah,
attach
yeah.
this on the back, or
Yeah, it's behind the rear view mirror.
behind the rear view mirror?
As a matter of fact, we already installed tens of thousands of units in the United States, include trucks and buses.
So if I'm just a consumer and I decide I can go into a store right now and I can buy this?
Yes. Hundreds of installations.
And how much would that cost me? Just,
$400, $500.
okay, so it's obviously cheaper if it's installed automatically into the car as opposed to.
But the important part is that the results are amazing. We show reduction of 37% in traffic accidents. So just imagine what it can do for the United States.
Well, presumably then the insurance companies might reward you and you could end up
It's our
saving
next
money on
step.
the... What you need to do is get the insurance companies to...
In Israel they do. They give it for free for young drivers.
I think America's a bigger market.
So we believe that with strong cooperation with the government, we can prevent 500,000 injuries and save 8,000 lives each year.
Well, that's
And this is only United
tremendous
States.
saving in lives and billions of dollars.
It's billions of dollars. It's hundreds of billions of dollars.
Congratulations.
Thank you very much.
Thank you. Good work.
We want to show you live demonstration.
Oh, you were going to do it live? Okay, go ahead.
So this is the system watching this video. So this is what's going to is actually a live demonstration. And while my partner is driving, this is what the system does. It sees the lane marks, recognizes the lane marks. This has a relation to the vehicle. Now we'll try to simulate an accident. So get closer. That was the warning that you are getting too close. Now, built-in cars, it will also play.
Is there noise that you got to filter out, presumably, so that you're not stopping and starting and hearing this all day long?
No, it happens only when you are really, the time to contact is very, very small. So he's trying to deliberately do it. If you drive normally, you don't hear this.
He's not a very good driver, though. That's
No, I'm not a very good driver.
Thank you.
Thank you very much.
Good job. Thank you. How are you, my friend?
Fine, how are you?
Good to see you.
Good, thank you.
this
Did you have a
is
good
wonderful.
night rest at least?
You know,
I got
it wasn't long, but it was
Hello.
good. How are you?
I'm fine.
What's your name?
I'm Azar.
Shalom.
Said hello.
Nice to see you, Shay.
Nice to see you.
Let me tell you a few words.
I'm the general manager of System Israel.
So nice to see you.
Same here.
I just saw John Chambers a couple days ago.
He sent his regards.
Absolutely.
Let me explain in a few words what is the story about. You use the word Hineni. Hineni means here I am. This is called Ma'an Tech. Ma'an in Arabic, we are with you. We are with you technology. So it's Ma'an Tech. Now, the Arabs in Israel feel discriminated economically. It's right. The reason is they don't have high tech. The Jewish part is more high tech, and the Arabs don't have. There are 60,000 academicians, academicians in Israel. Most of them are employed basically in teaching, but many of them are unemployed. So John Chambers and myself decided to do a special project to bring the Arabs engineers to the Israeli existing high-tech and to bring new high-tech to the Arab.
Oh, that's great. It's a great idea.
Now we started, and 30 companies, American companies, that work in Israel agreed to partake. Since then, 600 Arab engineers are working in high-tech Israel, and we started to do it abroad.
That's a great idea.
Yes. Now, it became a model for the world. John Chambers said, we can do it all over the world. These are two of the students. Please, present yourself.
As I said, my name is Al Zahar. I'm 23 years old. I'm original from Nazareth, but my current city is Beersheba. I'm also the ambassador of ManTech at Ben Gurion University of the Negev, where I'm doing my bachelor degree of information system engineering. And I also work at a startup called Telestart, where we develop an application for iPhone and Android.
Excellent. So you're going to school and working at the same time?
Yeah.
Well, you're very busy.
Yes, I am.
I am Saeed Farouk. I am 26 years old. I'm Palestinian. I was born and raised in East Jerusalem. I work at Intel as a hardware engineer, designing the next generation processors. At the same time, I'm doing pursuing my master's thesis in computer engineering at the Technion.
Excellent. Where did you get your undergraduate degree?
I took my undergraduate degree from the American University of Beirut.
Excellent.
Yes, this is what I told you yesterday. The companies are doing it voluntarily. Chambers invested over $15 million of his own money, of the company's money. They want to do it all over the world, and it's workable.
Well, it's a great idea, and presumably you guys are identifying some talent.
Definitely.
Being able to bring them in.
There's a big talent in the Israeli Arab community. I believe the high-tech sector can make a leap jump if you embrace.
It's a very important source of growth for us.
Because one of them,
and these are great people.
One of them, I think, is a candidate for the Nobel Prize. He has invented a machine which is called nano-nose, which means a nose that can smell cancer. You don't have to go into the body, and you can discover it at an early stage.
This is part of nanotechnology?
Yes. So, I mean, all this, that's what I try to say. It's workable. It's done voluntarily. These 30 companies are helping us to employ women, just to employ religious people. So they do it willingly, devotedly. They feel they're doing a job for the community. They're very proud. And we can do it all over the world.
Well, it's a great idea.
So that's what I meant yesterday.
Yeah. No, we were talking about this.
Yes. And yes.
It's inspiring to see these young people. Let's get a good picture of these young people. Come on.
Yes. Please come. No. It's the lady coming. Wait. Please stand on the side of the president. Yes. That's all right. Yes.
I'm very proud of you. Keep up the good work.
Thank you.
Keep up the good work.
Thank you. It's my pleasure meeting you.
Thank you very much.
Okay. So I'll see you this evening?
Yes.
Well, thank you so much.
Don't eat too much in Ramallah. That's something powerful.
I'll save my appetite.
Good. Thank you.
Thank you. Simon's point is companies can do better than I wonder how it could be. Good to see you. What's your name? Rami. Who's this? Good to see you. So nice to see you. Smile. Thank you. So tell me what you've got going here.
Yeah, so we are honored to present you the Mind Desktop project, which is started as an undergraduate project in the University of Ben Gurion. And its objective is helping for people that cannot operate a computer using mouse, keyboard, or any other means except their thought.
So you got somebody who's, let's say, paraplegic. They're trying to operate.
He can use this.
They can use this.
Yeah.
To use any computer in any sort of way.
And it wouldn't be fair to say they're just read your thoughts, but you can signal and activate.
So we identify the pattern,
your brain patterns
of your brain waves, and not exactly know what you're thinking about.
But so you're wearing this, and let's say I want to move my wheelchair.
We will show them.
Okay,
so first of all, we use a US product that analyzes brain waves and is able to detect a previously recorded thought to signal to the computer to do something.
Right.
And now, while I'm explaining to you how the computer operates, Ori will actually now open Outlook and check the calendar for today's meetings.
So he's doing this right now?
Yeah, he's doing this right now.
No hands.
No hands.
Concentrate though.
It's hard. He have recorded previously 3 thoughts. For example, assume he recorded a thought about a flower, a thought about his favorite song, a thought about his pet. And when you see this colorful box, as you see, one of them is selected. When he thinks about a flower, he zooms in to the selected area.
That's amazing.
Yeah, when he thinks about his favorite song, he selects a different area each time. And for example, he can zoom out by thinking about his pet. And
So you establish a baseline in terms of what the patterns are ahead of time, and then from that point on, you basically are laying on top of that baseline.
Exactly, with this interface.
With this. Interesting.
Yeah.
Great
With
idea.
only 3 thoughts, you can operate the computer type with a virtual keyboard.
What about the reverse direction, what the President alluded to? Is it possible to get to the point where we'd be getting...
I think it's a little too subtle.
It
depends on who we're talking about. These guys are much. You can never have their thoughts. Us, it'd be easy because our thoughts aren't that sophisticated. But this is remarkable, and it's. But I understand how. Actually, with just 3 patterns, I mean, it's not as if you need.
You could get
30 patterns. I mean, it's almost
only 3 patterns. Select next, zoom in, cancel.
3 degrees of separation from anything.
Exactly. It's almost like just setting up a binary system where you can just, you're just turning switches on and
And you
off.
can also type whatever you want and use it completely. Any computer.
Is this in use right now? Is there a prototype that is being used?
We tried it in a few schools with children, and it's now developing.
So you're starting to test it?
Yeah.
Do you have a company?
Great idea.
Thank you very much.
It's still development.
Great idea.
Good luck.
Congratulations.
Great
Thank you.
Great thing for people.
That's some smart stuff. Oh, okay. Good. Thank you.
Well, this is the most inspiring of all.
Hello.
Hello.
Good to see you.
Good morning.
This is our professor. He's done this. He invented this.
How are you? What's your name? So nice to see you, Sergeant. Where are you from originally? Long Island? I couldn't tell. Well, it's my honor. It's wonderful to see you. So you're just here for a visit, then?
Yes, sir.
Well, fantastic. And what's your name, sir?
Radikayus.
We've got a habit of we got a tradition of giving a presidential coin for our veterans. So thank you for your service.
Radi was in the military. He's from a Druze village in the north of Israel. He was wounded in action and supposedly could never walk again.
Well, this is amazing. So tell me, Professor, about what we're seeing. How are you? Good to see you.
Okay. As you can see, first I'm very happy to present the Rewalk, which is a device that enables people that are paralyzed with down to walk ascend, descend stairs and so. And it is intended to be used from morning to night, all day long. The Rewalk is an excellent example of U.S.-Israel cooperation, starting several years ago with the Belt Foundation, and we are very proud to be partnering with the leading rehabilitation centers in the U.S.
There's a good one in Chicago.
Pardon?
There's a good one in Chicago, the Rehabilitation Institute.
Yes, sir.
Did you spend some time there? Or?
We tour.
You guys tour?
Yes.
Fantastic.
So the VA is a great partner of us, and they, I would suggest that Terry here, Sergeant Terry, will say a few words about the device.
I'll tell you, we're hoping that the FDA is going to approve this to try to, in 5 minutes, try to have you understand what this means to us, to stand again.
Absolutely.
It's hard, but you have children, you have a wife, and you hug your wife, right? And in the chair, imagine trying to have a hug like that.
Yeah, well, it's easier to hug, you this way. It's easier to hug you this way. Absolutely. So I'm going to look at you from behind here. So
Yes, sir. I'll be more than honored to walk you down to the next room.
So this is like a
So the exoskeleton, right, doesn't feel, the user doesn't feel the weight of the device. The device carries itself down. Now there is a tilt sensor, the side of the
Right. Senses me. In other words, I'm not, when I press the button, it's not a robot. It's not walking. I must walk myself.
Right.
And I have control everything. So the benefits is not just standing, medically wise, our kidneys, our lungs, our hearts.
Everything's moving.
Everything.
Right, you're getting exercise.
Yes.
The muscles aren't atrophying, you're using them again.
Correct. No breakdown of the skin. We can be normal. We can visit our parents. We can go up and downstairs.
That's good. Now, in terms of utilization, what are the constraints in terms of who would be able to use this and who wouldn't do it?
Presently, it's half digits, like waist down, able to hold crutches, not like rainbow type hands, but hold crutches because it's only stabilization. Right now we're working on a device which suits people like me with quadriplegic, with problems with the hands, and later on like hemiplegia, half body, and the multiple sclerosis, and children like sickly children.
Well, you know, Michelle's father had MS, so he used crutches until he was probably 45, 50. And then eventually use a wheelchair. But this would give him a different life.
I'm 20 years, never stand. Now I can stand, I can walk. I can everything is normal, I can talk eye to eye.
Absolutely, it makes a big difference.
Yeah, it's different.
Not only, it's also feeling dignity.
This might be the major self-esteem.
How and how is there a limit to how far you can go with these?
No, sir.
So if
I've done a marathon.
So if you want to take a
yes, sir.
If you want to take a walk
next week, I go to 10K in Tel Aviv marathon in 4 hours. I walk.
And in terms of going up and down stairs,
everything, sit, stand,
Yeah, there are a lot of safety issues there. Sure.
How long does it take to train somebody to be able to use this?
They stood me up the first day. By the end of the week, I was walking.
That's great. Well, we got to get a picture of this. Let's walk.
Picture.
Simply all I'm doing, sir.
Let's get a picture first and then we'll walk down.
Okay.
All right?
You tell us.
No, this is good. You got this page? Yes, sir. No, we got your chief of staff. My chief of staff's the same way. We always want to get the picture first. We always obey.
I don't think it's to the height.
I just want to walk up and get the picture of Marty there. So now just to get a sense of sort of motor control, so what is it that you're controlling?
Find the balance. You see, I must to learn to find the balance. If I find the balance, it's easy to walk.
Once you have a balance.
What happens is they programming, they know how high my leg must come to clear the floor and my foot to clear the floor. They take that information, they put it into the computer. So there's a set program. So now anytime that I want to walk, all I do is simply, there's a watch, and it has silhouettes on the watch for the stand mode, walk mode, sit mode. Just put it in that mode, trigger it, and I'm gone.
One thing is that the walk is natural, kind of intuitive. The person doesn't have to, shouldn't think about walking. Just pushing crutches. Just pushing crutches, and when she wants to stop, just stop pushing the crutches, and the system converges to a stance.
That's terrific. Congratulations.
Last time we did
we're so proud of you.
Because of the gaming. All communication. Now we have 5%
ממש הרגש לראות את זה.
Thank you, sir.
Thank you for your service. Very proud of you. Congratulations. God bless you. Well done so much.
What hope.
Very proud of you. Thank you very much. Congratulations on your great work. Thank you very much. Thank you. Thank you. And so it'd be, so the VA and
Anytime you want us to come and demonstrate it, we'll be more than happy.
that's good to know. Good. Excellent. Well, thank you so much.
Thank you, sir. Thank you for taking the time.
That's very inspiring. Thank you.
Welcome to the password table.
So these are the smart young people.
And this is the educational problem will be presented by students.
Good to meet you. So nice to see you. So I need this for my Seder table. Okay, let's see what we got.
Actually, we built robots in a joint project for the school and the deaf language.
How old are you?
All of us are 60.
Okay. I remember that age vaguely.
We learned about science and technology in this project. Last year, we won the RoboWaiter competition in Connecticut.
Excellent. Congratulations. This is an international competition, a robotics competition.
Yes.
The idea of the RoboWaiter competition is that robots can serve people with disabilities. In our course, we built robot models and we built them from kits. Because of the fact that Haifa and Boston are sister cities, we want to develop a collaborate project.
The robot waiter task is to serve food, and because the Passover holiday is near, we want the robot will serve you a matzah. Let's run the robot.
Okay. Okay, there you go. Cheers. Okay. That's good mustard right there. And that's the robot for some salt. Well, that's wonderful. Come on. Come, let's take a good picture. Congratulations. Come on, Fantastic. All right, well, you guys keep up the good work.
Thank you.
So nice to meet you. Very nice to meet you. Thank you. Great job. Keep it up.
One of these kids will probably make
So nice.